Everybody, and thanks for this opportunity. It's been great so far just listening to everybody else. Gary Hilkema, I represent SensorLink here. We've been in business since 1985. Next slide, please. What we are going after is the demands on utilities. We want to help them deal with the pressures from consumers like you and I and the government to support green energy initiatives, and we want to give them the chance to address these issues. These demands give us an opportunity to provide precise grid edge data collection. Next slide, please. It's a worldwide issue, guys. There's demand for reliable energy in certain parts of the world, and in others there are the need to meet government initiatives that are going on. Next slide, please. Our vision, which is based on the changes occurring in the world, is to aid the electric utilities in protecting their revenue, and adapting to new market demands, costing them billions of dollars over the next decade or two for the changes they have to make. Next slide, please. We know a lot about the demands in electric utility because we have been selling into the utilities since 1987, and our core technology is a patented Rogowski coil developed for measuring current in high voltage environments. Next slide, please. We have worldwide distribution right now, so this map represents all the areas and countries we've sold products into. And we have an established rep and distributor network as well. Next slide, please. That network has allowed us to sell our core product, shown here, which is an AMSTIC, into 83 different countries. Next slide, please. We've also had sensor developments with other partners that have played a key role in our growth over the years, and these are a list of some of the companies that we've been able to work with. Next slide, please. What's the opportunity? Our opportunity is to monitor distribution transformers, and our approach is with a low-profile sensor that we're naming the TMS-XT. It's going to provide data at the source to make key planning decisions for overload prevention, theft detection, and power quality. Next slide, please. The TMS-XT is capable of taking accurate measurements, giving the utility the data to plan for changing load profiles on the grid. And the need is for them to get it right, especially since they're going to be spending billions of dollars over the next decades to meet these demands. So it's not so much about how much they are going to need to spend, but it's going to be more about where to spend it. And we need to give them a chance to protect their revenue from theft, which in some countries can be upwards to 30% of the power generated, and it's just billions of dollars being lost as well. So, and then on top of that, they have technical losses that we also can help them with. Next slide, please. Based on our research, expertise, experience, we have designed this sensor to be a live line installed in less than 5 minutes. It weighs less than 1.5 pounds, and it's difficult to visually detect from a distance. Next slide, please. Cellular communication is going to be the targeted method for transmitting data to a remote server with options of simple software for retrieval of the data, or will allow for integration into other enterprise solutions. Next slide. It is estimated today that there are over 2 million distribution transformers installed worldwide. Next slide, please. Which we've estimated or set as our potential market 180 million, which is 0.1% of the 2 million installed. Next slide, please. There is some competition. Grid 2020 has a product, as well as there's a product called AGI LV node, and these two types of systems are installed on existing transformers, but with highly visible boxes. And for the AGI node, it takes some time to install it and putting it on the pole. The smart transformers and smart meters require significant investment in replacing a lot of existing equipment, amongst some other issues. So what makes us better? And what makes us better is, next slide please, our ability to be extremely accurate with a discrete sensor. Our combined cost of installation and per unit cost is much less than our competition, and our sensor is capable of partner integration. Next slide, please. What are we asking for? We're asking for $1.5 million. We have final development into certain areas, as we can be seen here. There's tooling and manufacturing that need to occur, and then going to market worldwide. Next slide, please. Our core team that has been doing this for some time, Darren has a team of mechanical and electrical engineers. Chad has a team of assemblers, manufacturing, and Tanea and Nate manage our sales system throughout the world. Everything we design, we also manufacture here in Ferndale, Washington. Next slide. Thank you for your time. If there's any questions.
Go ahead, Stan.
How did you come about the 0.1% target market of all the transformers? Is that based on industry practice? What is that based on?
It's based on the transformers in certain areas that are literally going to be needing some sort of monitoring. So, for instance, high-use areas where there's going to be outfitting different transformers, or the need to have more load on transformers. We realize a lot of transformers are installed in areas where their use is not have such a high demand on them, or due to the changes. So it's based on clusters and areas where there is a higher demand for some of the changes that are going to be occurring.
Okay, and since it's a heuristic, I guess, is it conservative, and is there an upside?
It's a very conservative, and there is an upside. There's an upside to 2%.
Thank you.
Yeah.
This is Diana Grauer from Technip FMC. Do you need one unit per transformer, or if you need one per line, how is that set up in working order?
Correct. Yeah, it is one per transformer.
Hey, Gary, Josh here from Anzu Partners. Cellular transmission usually takes a lot of power. So my first question is this battery powered, or is this plugged into the grid? My second question is, what type of maintenance are these sensors going to require?
Right. So the unit is powered from the line itself, and it's a low power transmission. So we're not pulling very much from it. So yeah, it's powered up because it has the two connections. We have voltage there, so we have power. So it's fully powered. It does have a battery backup for last gas if the can or the transformer goes out, or if power goes out, that we're able to still trickle and continue to have the chip going still until power comes back. But it is self-powered. And as far as maintenance goes, once installed, these are intended to be and designed to be built for permanent install for 7-10 years. As far as maintenance goes, they are a minimal maintenance, very minimal, if any.
So you said that This is Diana again. What's
Go
the
ahead.
design life of the sensor?
The design life is 7 to 10 years.
Is 7 to 10 years. Okay, thank you.
Go ahead, Josh. You want to ask a question?
Yeah, Josh Gould here from Duquesne Light. How do you work with utilities to determine which to deploy in what distribution transformers?
Yeah, we're going to be relying on the utilities to be able to work understanding that. We also have a recorder product that does do recording on the high side, on the high voltage lines, that will be able to help them plan accordingly to bring these down to monitor directly to get more granular and more consistent data. So we do have some planning tools that allow them to pinpoint where they need to put these at.
And just one quick follow-up. Have you used those planning tools when you've deployed with utilities in the past?
Yes, the recorders, one of the first slides, we've sold over 7,000 of those recorders throughout the world for that purpose of planning, load planning, selling to the engineering departments throughout the world.
All right, William, you want to ask the last question?
Yes. So I noticed, I believe, on an early slide that you spoke to how this addresses and helps with reliability. My question is does this do anything to help with resilience? A significant amount of our effort and focus is making sure our solutions do improve resilience of our power systems. So I'm curious if you have any ability to speak to that.
Again, the resiliency data, so outage management systems, is that being able to know the temperature of the unit, to know the temperature of the transformer, partial discharge, some of the transformer life and health from a resiliency standpoint. Is that what you're focused on?
No, I'm talking about like for what we saw in Texas with ERCOT. Does this help those extreme events?
Right. Yeah. So what it could help in things like that is when they're receiving data back to receive alerts on which transformers could be overloading or overheating, and they would have to still have other things in place because these are not connected to the transformer to have an action occur to that transformer.